Hello, my dear student. In this video, I will discuss how to find basis and dimension of a vector space. Now, try to understand the question. Find the basis and dimension of the subspace S equals to x, y, z belongs to R cube colon x plus 2y minus z equal to 0 and 2x minus y plus 3z equal to 0. Okay. So first solution is, so the given subspace is, you write down S is equals to x y z belongs to R cube colon x plus 2y minus z equal to 0 and 2x minus y plus 3z equal to 0. Okay, so first you need to write down these two equations, that is x plus 2y minus z. Okay, so here we may write let x1 y1 z1 be any arbitrary vector from S. That means this must be satisfy this relation also, that is x1 plus 2y1 minus z1 equal to 0, 2x1 minus y1 plus 3z1 equal to 0. Now there are two simultaneous equation you have. So if you can recall from class 7 8, you know cross multiplication technique. So okay, clear. So now we need to find the value of x1 y1 z1 by using cross multiplication technique. Now, so here you may write x1 by y1 by z1 by, clear. So x1, that is 2 into 3, 6, coefficient of this, that is 1, minus y, x into this, that is 1 into 3, this into this, from z, for z this 2, 1 coefficient minus 1, that is minus 4. Is it clear? When you are considering x, you need to calculate y and z component. When you are considering y, except y, x and z component, and for z, x and y. Clear? So ultimately it is coming x1 by 5 is equals to y1 by minus 5 is equals to z1 by minus 5. So ultimately it is basically ratio, all 5 are common, so you may write x1 by 1, y1 by minus 1, z1 by minus 1 is equals to k same. So from here you may write x1 is equals to k, y1 is equals to minus k, z1 is equals to minus k. Clear? Clear? Okay, very good. Is it clear to all of you? Please write down. Please write down. Okay, so therefore you may write therefore, that is x1 y1 z1 is equals to uh, k minus k minus k. So k is constant, so 1 minus 1 minus 1. So from here it is clear that x1 y1 z1, what is x1 y1 z1? Basically x1 y1 z1 is an arbitrary vector. So from here it is clear that in this subspace all vector can be expressed with respect to this vector. For different values of k, we will get different vector which is satisfy this subspace. Okay, so from here it is clear, that that every vector of the subspace S can be expressed as a linear combination of the set of vectors 1 minus 1 1 1 minus 1 minus 1. Okay, so the basis set is, so first of all, if we want to prove a basis, we need to prove the set of vectors linearly independent, as well as all vector can be expressed with the help of this set of vector. So from here it is clear every vector of S can be expressed a linear combination of this vector. Okay, as well as how many vectors you have in this set. Since uh, since the set 1 minus 1 minus 1 contains only one vector, so 1 minus 1 minus 1 is linearly independent. Okay, so if one vector is there, no comparison, so one is independent. Okay, independent, so therefore the basis set is this one, 1 minus 1 minus 1. Clear? Now dimension. What is the dimension? So how many vectors you have? 1. So dimension is it clear to all of you? Is it clear? Okay, very good, very good. Clear? So if you want to find the basis, you need to prove that the set of vector is linearly independent, as well as all vector can be expressed as a linear combination of this set of vector. That means this one. So here you have only one vector. So if you please remember, if you have any set contains only one vector, this set is linearly independent. Directly you may write. Okay, clear? Okay, very good. Okay, so now we are going to solve. So here in this problem we have considered two simultaneous equation, but there may be a chance to see only single equation. Now try to understand, if you have only single equation, how to solve it. Now solution. Okay, now try to understand. Let alpha is equals to alpha, no need to write. Let x1 y1 z1 z1 be any arbitrary vector from S. So that means this vector must be satisfy this relation. So therefore you may write x1 plus 2y1 plus z1 equal to 0. Clear? Now, so from here you may write x1 is equals to minus 2y1 minus z1. Okay, so now therefore you can check, that is x1 y1 z1. This line is very very important. So you are replacing x1 is equals to how much? Minus 2y1 minus z1 comma y1 comma z1. Okay, so now please check. There are three components you have. What is the coefficient of y1? What is the coefficient of y1? Hmm? What is the coefficient of y1? Very good. Y1, that is -2. From here, third component you have 1, 2 and 3. So here it is coming 1, and here did you have any y? No. So it should be z. Clear? Clear? Okay. Plus z1. Now again you write in this first component, what is the coefficient of z1? -1. What is the coefficient of z1? 0. What is the coefficient of z1? 1. Is clear? So first, you suppose you have a question in your mind. Okay, first you need to clear your doubts. So first we are from the relation we are eliminating x1 from here, that is -2y1 minus z1, that is x1 y1 z1, you may write -2y1 minus z1. Then rest of the part y1 z1 same. From here y1 is a coefficient, it is -2. From here is this 1 and it is a 0. Then z1 is -1 -1 0 1. So from here it is clear uh, that this vector is arbitrary vector, so this vector can be expressed as a linear combination of these two vector, correct? So clear? Suppose you have a question in your mind, sir, you have considered x1 is equal to something, can I consider y1 or z1? Yes, you can. According to that your vector will be replaced or maybe different. Clear? Clear? So now we can come to the next slide. So from here you may write uh, since since x1 y1 z1 is an arbitrary vector. So uh, so therefore every vector of S can be expressed can be expressed can be expressed as a linear combination of the set of vectors, that is -2 1 0 and -1 0 1. So first condition is over. So that means uh, you can express that is this set of vector is a generator. Okay, that means representative, you can say. Okay, now you need to prove this set of vectors linearly independent or not. Now please write down. Now we want to test whether the set -2 1 0 -1 0 1 is linearly independent or not. Okay, so already you know how to prove linearly independent. Anyone? That is very simple. C1 alpha 1 C2 alpha 2 plus dot dot Cn alpha n should be equal to null, where null theta, where C1 C2 all are constant. If you can prove that this line is valid where C1 C2 all are constant 0, then only you can say the set of vector is linearly independent. Okay, so now we want to test it. Clear? Okay, please write down. Now C1 -2 1 0 -2 1 0 plus C2 -1 0 1 -1 0 1 is equals to theta. Theta means 0 0 0. Basically already you know c1 alpha 1 c2 alpha 2. Here it is theta, so here alpha is equals to this, beta alpha 2 is equals to this. So from here you may write, we want to prove, if we can prove it that c1 c2 are coming 0, then this set of vector linearly independent. Now let's see whether it is coming or not. So minus 2 c1 comma c1 comma 0 plus minus c2 comma 0 comma c2 is equals to 0 comma 0 comma 0. So if I can add component wise, it is coming minus 2 c1 minus c2 comma c1 comma c2 is equals to 0 comma 0 comma 0. Clear? This plus this plus this plus this. So therefore you may write minus 2 c1 minus c2 equal to 0, c1 equal to 0, c2 is equals to 0. So from here it is clear that c1 c2 are coming 0. So therefore hence minus 2 1 0 and minus 1 0 1 is linearly independent. So already you have proved linear combination can be expressed, as well as you have proved linearly independent. So minus 2 1 0 and minus 1 0 1 is a basis of the given subspace. Okay, now the dimension is how much? How many vector you have? 2. The dimension is 2. That's all. Clear? So this is all about the process to find basis and dimension of a vector space. There may be two situation, maybe single equation, maybe double equation. Okay, thank you everyone.